AI has a fatal flaw and nobody can fix it. Let's see what this video has got.
Take a look at this line. This is a $100 million line, probably the most expensive math equation in history. It's a limit, an imaginary wall of physics and mathematics, how intelligent artificial intelligence can ever be. So take a good look, because I promise I'm not going to show it again in this video. Like, I'm not pretending this is a science channel, so we're not going to go that deep. But I will explain in the simplest of words why there's a limit to how smart these models can get, a limit that even the top scientists have not been able to overcome.
Yeah, that's probably because we have limited resources, resources of energy, electricity, and limited hardware.
And the clues about this have already started to show up. And this is the equation, that was the equation that might put an end to all this bubbly behavior around AI. So for years, we've been imagining an artificial intelligence that outsmarts us. But let's get something out of the way. Computers are already way better than us at plenty of things. Computers absolutely kick our ass at solving math, and they're definitely smarter than us at storing data and reciting it back. That's
They are.
not really intelligence. Current AI companies have even had to differentiate our current AI from AGI, artificial general intelligence, because they know deep down that what we have now is not really intelligence. But assuming that we gave hands,
Yeah, current AI is like a machine, is like a phone, is like a computer program. You just give a task, it gives you the output. That's all it is. This is not only me saying. If you go and look at Neil deGrasse Tyson, he also says the same thing. It is just a machine right now. In the future, I don't know what's going to happen. Maybe doomsday.
to a GPT, could it actually cook me an egg for breakfast?
Mm.
The fact that AI is the buzzword of the year and that NVIDIA is worth some $1 trillion number is based on three premises. One, that the smarter models are going to need all of those GPUs. Two, that more people are going to adopt AI into their daily lives. And three, that our AI models are going to get exponentially smarter. Everyone is in panic mode because some Chinese startup allegedly built and trained at
And the other thing is, this video came out like 10 months ago. So this is related to DeepSeek a little bit.
ChatGPT level model using a fraction of the compute cost and a fraction of the cost.
One Chinese startup just launched a new AI model to rival OpenAI.
DeepSeek has become the most downloaded free app.
Passing ChatGPT, which is pretty shocking.
I'm going to get this. It remains to be seen how much the average Joe or the average company adopts AI into their lives, but none of those betting on big tech's AI transformation are even questioning the possibility of that third bullet point. And therein lies the problem. Making our current AI models smarter is almost impossible. In order to understand why that math equation is so dangerous to these companies, we need to understand at least the basics of how our current models are trained and how they think. So let's just go to our explainer time.
Yeah, the main role is the transformers role, which Google developed back in 2017, 2018, like 8-9 years ago.
What GPT excels at, to the point where it acts like an intelligent, sentient bot, enough to fool many of us, to write entire essays. What it does is predicting the next word in a sentence. But being really good at predicting words or the next word already allows a model like GPT to beat us at most standardized tests, which is kind of the way we measure our own human intelligence, isn't it? And yet, GPT doesn't do that well at math. It only beat about 50% of the students in these tests. Why is that? Well, one number that you're going to hear about all the time when people talk about these models is the number of parameters that a model was trained on. How many parameters is a model using? GPT-3, for example, which is almost useless, dumb compared to the models that we use today, used 175 billion parameters. What the hell does that mean? So let me show you. Now, a model like GPT uses pre-trained transformers to generate text, hence the name. Now, this sounds like nonsense to you right now, but I promise it'll make sense in exactly 4 minutes. Imagine that we feed the model a sentence so that it can try and predict what the next word is. So the first thing that the model needs to do is try to understand what this group of words mean. Like, we're seeing words here, but the computer is really just seeing bits out of all this thing. And the first thing that
transformer is the one that plays the big role here to understand what's the next word. One ring to rule them all. That's what I would guess, because I've seen that sentence somewhere before, and this is the same thing the current AI does.
What we'll do is try to break this into tokens. Maybe you've heard the term before. Then what we'll try to do is classify those tokens based on their meaning. LLMs classify words by grouping them together with words that have similar meaning. Technically, this is done not by grouping entire words, but tokens, which are fractions of a word. But I'm going to stick with the concept of words just for simplicity's sake. For example, ring may be classified with other words like ear, like jewel, maybe around the world circle. So here's a 2D, simple, two-dimension axis. We have a horizontal axis X and a vertical axis Y. This is great for numbers, right? Because we can just go up or down depending on the number. But we're dealing with words here, and there are thousands of words out there with thousands of different meanings. It would be kind of impossible to group words by meaning into a 2D space. Even in a 3D space, we'd run out of directions to go to very quickly. So GPT-3 classifies words, or tokens really, into 12,288 different dimensions.
Whoa, whoa, whoa. That's a lot of accesses. It's like 12,000 dimension. It's not even 3 dimension. It's not even fourth dimension, fifth dimension, 12,000 dimension.
That means a grid with 12,288 axes. We can't see it, of course. We can't even imagine it. It's like that interstellar tesseract, but with 11,284 more dimensions to go.
Hmm.
But don't worry. Well, what you need to understand is that in this unimaginable cloud, this black hole of directions, words with similar meanings are going to be grouped close to each other. So from the GPT-3 paper, we know that OpenAI used about 50,000 tokens, basically a dictionary of tokens, and it mapped them into this 12,000 dimension space, which already puts the count of parameters that the model is going to need at around 600 million. Still, that's far from the 175 billion parameters that GPT-3 had, so let's keep digging. But before I do that, I want to take a moment to thank NordPass for helping us fund today's explainer. NordPass is a secure
Well, let's skip the ad promotion. Let's skip it.
So the mapping of words into this incomprehensible tesseract black hole is called embedding. This is the embedding step. It's how a model turns words into something that computers can understand, and process. But just understanding that the word ring lives in a neighborhood of other words, we still don't know what it means in this context. Ring might be a sound, might be an earring, might be the one ring. So how does the model know? And so that's where
Yeah, it's the context around it.
transforming comes in. What the model's going to do is transform the word, essentially move this word in this 12,000 dimensional space, this specific sentence, it'll move it closer to the meaning that's based on the context around this specific word in this sentence. So that context could be the word before, the word after, could be the words mentioned earlier in the conversation. For example, the model might notice that this R is capitalized, even though it's not at the beginning of the sentence. Must mean something. It might also look at adjectives and how they affect nouns. So this transformation layer makes tiny adjustments in the region of space where this particular word lives. Now, all of these transformers are going to run at the same time. And that's in part why
And you see the transformer I was saying earlier, this is the thing that helped to develop AI.
GPUs are so good at doing this thing because they were built to calculate all the pixels in your screen at the same time. Now, each transformer in GPT-3 has about 1.8 billion parameters. Around 600 million of those parameters are in this first attention layer, which helps focus the word in space. And about 1.2 billion of those parameters are in the feed forward network layer, which is kind of like a zoom in on the meaning of the word, but that's as far as we're going to zoom in today. Now, GPT-3 uses 96 of these transformers for a total of almost 174 billion parameters. We're almost done. Now, the last few parameters are on the output layer, which
Now then comes the output. So it takes the input, it understands what's the context, then it gives you the output. Okay, this is probably the thing that fits here. Like here, wanting to rule them. The word could be anything. You embed a word, then transformer goes and finds the context around it with all the data that it is trained on, and then it gives the output. Okay, is it all? Is it it? Is it this or that? Or like it gives a word and it fits here. One ring to rule them. What's the word? Maybe all, right? And that's all.
actually does the unembedding, the inverse of the input layer. It brings this word, these 12,000 dimensions, into our old 2D bit world, and it gives us the result of this massive operation of the model as words, not as numbers. The result of this massive mathematical journey.
But this video might get copyrighted because of music. So I'll just remove the parts where the music is added or where the YouTube shows the copyright. So yeah,
Is a list of
take care of that in mind too.
words, along with the probability of which word comes next. Now, the whole idea of machine learning is that we don't have to go to train each one of those 175 billion parameters to tell it what it needs to do. It learns itself, aka machine learning. Now, the first time this runs, this thing is going to spit out just gibberish. But during training, the model will adjust these parameters using algorithms to reduce these errors. Think of them like small knobs that slightly move to generate slightly different mathematical outcomes in the end. It's like trial and error on a trillion scale.
That's called reinforcement learning. If you do this thing correctly, you get a reward. If you don't do this, you get a punishment. And whenever it gets a reward, it starts to develop, okay, this is the correct thing to do. Same as human behavior.
If a particular set of values helps the model make a correct prediction, those values are reinforced. If not, they're adjusted. Each of these connections between one value and the other is a neuron, which makes a neural network. And it works not so differently from human neurons. Like, it may sound impossible, but after billions of operations and training data, this thing can actually and pretty accurately predict the next word in a sentence. Again, this thing has consumed billions and billions of text written by humans and has become so good at predicting words that it can pass our tests. And predicting words is the LLM example, but you can apply this logic of predicting the next thing at how a pixel should look to generate an image, or understanding if this.
And the transformer was used in the words. Now we go from words to images, images to videos, and so on and so on. I think they will probably release something like for the real world, okay, what happens on this side? If you visit here, what's the next thing that should be present here? Something like that in the real world. And I believe the best use cases will be in the gaming.
This dress is blue or gold. Same basic principle. Now you know the reason why it failed the high school math exam. A pure GPT model doesn't do math, at least not directly. In the simplest of terms, if you ask it what's 1 plus 1, it knows the answer is 2 because it read a million times that the answer is 2, and it's incredibly efficient at identifying patterns, but not because it pulled up a calculator and added 1 plus 1. That's not bad.
Just because it was trained on 1 plus 1 equals 2. It is not doing calculation. Like if you go to a calculator and do 1 plus 1, then it gives you the result too, because it's doing its calculation. But on the AI thing, it's not doing calculation. It's just finding the answers. Okay, 1 plus 1 equals, what's the number that is likely to be there? Like it might be 3 if we were calculating 1 plus 1 equals 3. But the AI sees 1 plus 1 equals 2 on a lot of data. Okay, 1 plus 1 equals 2. So that's how it works.
That per se, but it's going to be a problem later. The thing is, once you have a computer that can understand these relationships within words, you can give it instructions in plain English, and it'll base its responses on that. Like this transformer model with an instruction on top of it is the same concept that Grok and Llama are using, and they're all limited by the same equation. Now, that 175 billion parameter GP3 model had problems. Like you could tell it was AI because it didn't write quite like a human. It couldn't count the R's in strawberry. It also had a rather small limit of context. How many tokens before the current word are processed and considered for the prediction of the next word? So let's just train it with more, right? OpenAI theorized that by scaling the amount of data and the amount of parameters, the model would get a lot smarter. And it did. A way to measure the
And that's where the OpenAI hit the wall, because they trained in like trillions of parameters and they hit a wall.
effectiveness of the model is with the error rate, so the word predictions that are incorrect. In very simple terms, it's more complicated than that. Effectiveness of the model is with the error rate, so the word predictions that are incorrect. In very simple terms, it's more complicated than that. But anyway, they projected the error rate decreasing the bigger the model was and the more data was used for its training. And so they went and did it. They spent over $100 million in training this thing. Leaked data from OpenAI says that GPT-4 uses 1.8 trillion parameters. It has more transformer steps, potentially with more dimensions for the tokens. And it took about 25,000 GPUs running for over 3 months to train GPT-4. But it worked. The results were way better than GPT-3. So let's just keep doing that, right? More GPUs, more data, more parameters. Well, that's when they hit a wall. Now, that wall is this formula I said that I wouldn't show you again, because you would think that a bigger model, in this case, the bigger the size of the model, the better the performance at some fantastic astronomical level. But OpenAI has kind of reached this wall of diminishing returns. It's kind of like, there's not a lot that we can do. Like, regardless of the size, we just can't get that performance up a lot. Even if we throw a lot more data and create neural networks with quadrillions of parameters, the improvements are going to be marginal. All the way through 2024, we had lived on this part of the chart, right? But GPT-5 failures seem to reveal that we've kind of arrived at this plateau right here. And that's not even the worst of it. So a recent paper concluded that there is simply not enough data to train them. There is a point in this curve where the amount of data needed for training is bigger than the amount of data that exists. We just haven't produced enough data that can be used for training, text, knowledge, images, speech, to satisfy the needs that the models would have to reach perfection or a very, very small error rate. So in other words, we have found the limit of the current machine learning.
That's what I was saying. Like you can't keep on going forward because you have finite resources. The only thing we have is the limited number of GPUs, limited number of energy, like limited number of electricity.
Algorithms. The models are flawed and humanity doesn't have the resources to train them. Let's be real for a second. Like this series of tubes, this transformer model is arguably one of the most important scientific breakthroughs of the century. And I'm focusing on language models here, but we have now built models to predict the shape of proteins, which seemed an impossible task for a human. If you wanted to produce an image of something that didn't exist, you'd need creative people, illustrators, Photoshop artists, 3D rendering, and now an AI can just deduce how something looks from previous training. Like, I don't think enough people talk about what this means for 3D artists. When we spent hours trying to build a new world from scratch, and now a computer can reverse engineer that from training data and just give us the same result in a fraction of the time. But it's not over, though. For years we thought there was no other way to reach this level of performance unless we had like 2 trillion parameters, billions of dollars in servers, and piles of training data. But it looks like there is a better way around it based on DeepSeek's efficiency with apparently a fraction of the parameters and the cost. We're yet to see if that's true. Still, I think it's only a matter of time before we find a more efficient way to do all this process easier and cheaper. But even more importantly, the answer may not be GPT-5 or 6 or 7. LLMs have proven that we can make a computer understand natural language, and so companies figured the next step was connecting other systems to that brain. And this is why GPT can now see images or recognize speech, giving eyes and ears to the system.
Hello there, cutie.
That eventually will turn into hands, but how far is it from cooking an egg or doing my dishes? There's some reasoning needed behind that. So this is the whole idea of what models like O1 and more recently O3 try to do. This model that we built originally just tries to spit out the next word as quickly as possible. But scientists came up with this concept of reasoning. Now, using the same transformer, the same model at its core, it tries to interpret the question and tries to break it down into smaller subtasks or prompts. And then it tries to solve each one of those prompts in order, kind of giving it like partial answers to your original question. Now, once that possible response is done, it analyzes it again to see if it makes sense against the original question and the original context of the conversation. So it does a bit like your own brain's thought process, writing that email response, starting over, readjusting, rereading before you hit send. Like this step-by-step process is called chain of thought. Again, not too different from your train of thought. But let's go back to that table that I showed you earlier.
Yeah, what they did was it was chain of thought. In OpenAI cases, they were doing step 1, step 2, step 3 to get the outcome. But in DeepSeek cases, what they did was step 1, but in multiple places. They did not go with the process. They did not go with the steps because it takes a lot. It takes a long time. They went parallel sequencing. It's like 2 lines are going at the same time.
This iterative thinking has actually allowed current models to beat us at general human intelligence tests. IQ, structured logic, decision-making scenarios. It's good enough to write basic and even some intermediate code. It's got a fair share of engineers struggling to find jobs, which would have thought that they were the first to be replaced by this. But anyway, in startups at least, there's an unspoken truth of the number of jobs that AI has already replaced, but it's very bad press and nobody really wants to talk about it. But when you get out of controlled environments and into the real world, that's where AI struggles. Like common sense reasoning, creativity, decision-making in real-world scenarios, and even advanced mathematics where...
Yeah, I would say AI is way bad at decision making because it does not know what you want. It does not know about your brain. And I believe Elon is heading towards that direction. He wants to connect your brain with the data, with these AI things. Yeah, I believe so. But it's not going to be soon. It's going to take at least like 20, 30 years. That's what I think. Am I wrong? Maybe. Am I right? Maybe. I don't know. Like, I don't know the future, right?
problem solving and some creativity is required. Like these models take minutes to process through all of this, and it still takes us seconds to make these advanced decisions. That's a processing and capacity problem, not an architecture problem. Also, what happens when these models are allowed to escape containment? When they can start doing things in the real world?
Operator is a research preview of an agent that uses browser.
Nothing happens because these models are not accurate. They don't know the real world data. They only know the theories data. It's like the difference between reality versus expectation. Like expectation is the theory that you wrote in the paper, right? But the reality is when you go into the real world, there's a lot of inefficiency you have to deal with, and that's where these models fall apart.
To help user to do things.
I'm not doing anything right now. The operator is doing everything by itself. It's okay, Mom. I'm here to help.
I think we just keep pushing the bar of what intelligence is. Feelings, right? Creativity, true invention. We still have some of those, and computers don't. But the set of human-only skills is shrinking. It's running out, and I think we have to deal with the reality that it's no longer an if, but a when question.
Do computers really think? Let's just say it all depends on what you mean by thinking.
Now, if you enjoyed today's explainer, you should watch our video from last week on how money gets created and why 93% of today's money doesn't really exist. Catch you on the next one.
All right, that was all.